Good evening. Welcome to all of you again. I think in last session we talk about. I think we talked till. I can say. We talked till. I think statistics. We talk about descriptive statistics, and then after descriptive statistics, I talked about probability, and then conditional probability. Okay. So these are the things which we talked in the last session, in yesterday's session, and I thought that every one of you is very much comfortable with every one of you is very much comfortable with whatever we learned yesterday, because I got like so many positive response from your side. Um and even this is very good that every one of you is able to answer my questions, whatever we have discussed in yesterday's session. So yeah guys, so I think today also we are going we go in a similar way, and today we are going to talk about this probability distribution kind of a thing. And this probability distribution is again a very important topic. Okay, so we are going to discuss a lot of things today. And again, just in yesterday's session, I talk about the significances. Okay, so along with the definition, along with the idea concept, I talked about the significance also. So in a similar way, today also, I'm going to talk about each and everything. I'm going to talk about the significance, what is its importance in terms of machine learning if you are having a real data set. Okay. And maybe today I will give you glimpse of Python also. Okay, because maybe we can go only in a theoretical way, but we can do if I give you a small scenario that how you can code in a Python, so you are able to code something at least by yourself also, and it will help you in future. Okay. So yesterday itself, I told you that just try to learn, or just try to go through this topic, probability distribution. So if any one of you can tell me that whatever you have search, or whatever you have learn about a probability distribution. So anyone can tell me, or anyone can write in a chat box that what do you understand by a probability distribution. No. Okay, so even guys, this idea, this probability distribution idea is very easy to understand, because okay, so what happened in a probability distribution? So probability distribution is nothing but it's a graph, or you can say a chart or table. Okay, where the values, okay, so where the values are lies on the x-axis, and the probability associated with those values are lie on the y-axis. Okay, so this is what a meaning of a probability distribution. Okay, so this is what a meaning of a probability distribution. Fine. So the values lies on the x-axis, and the probability associated with those values lie on the y-axis. Okay, and this is a way we are trying to draw the probability distribution graph or probability distribution function. So it is nothing but it's a graph, or it's a table, or it's a chart where we have our values on the x-axis and associated probabilities on the y-axis. Okay, so even if you want, you can write a definition for a probability distribution. So the probability distribution is a formula, table, or graph. It is a formula, table, or graph that gives the possible values of x and the probability p of x associated with each value of x. Okay. Now there are there are different probabilities distributions which are available. So even there are more than you can say more than 80-90 probability distributions which are existing, but we are not going to talk about all those 80-90 probability distribution. We and even we are not going to use it. Okay, so in our entire life we are not going to use like each and every distribution. Only like suppose if you are working as a working in a like research area, and specifically your like title as a statistician, then it may possible that you are going to talk about like each and every probability distribution. But if you are working as a even data scientist or a data analyst, or maybe like machine learning engineer, so we don't need like all the probability distributions to discuss. So there are like some common probability distributions like a binomial distribution, and even these distributions we are able to categorize based on like a discrete and continuous random variables. Okay, so we have a binomial distribution, then we have a Poisson distribution, then we have we have a uniform distribution, then if we have a normal distribution, or you can say a Gaussian distribution, and then at last we have okay, so binomial, Poisson, uniform, normal, Gaussian, and then at last we have standard normal distribution. Okay, so these are like all different probability distribution functions which are available, and these are the like main distribution functions on which we are going to like discuss. Okay, now even the as I told you that all these distribution functions are categorized, or we are able to make a differentiation based on the type of variable, based on the type of a random variable. Okay, so there are like two kind of random variables. One is discrete random variable, another one is a continuous random variable. So a inside a discrete random variable we have a binomial distribution, we have a Poisson distribution, and for in a continuous random variable we have a uniform distribution, normal distribution, and standard normal distribution. Okay, so guys, like one by one I will like show you that what are like all this what is the meaning of all this distribution. And even out of all this, two distributions are very much important. Two distributions are like very much important if you're like if I talk about machine learning. Okay, so if I talk about a machine learning or artificial intelligence, so two distribution function is very much important. One is a normal distribution and another one is a standard normal distribution. Okay, now let's check. So if I talk about a binomial distribution, so just try to discuss like each distribution function one by one. It will not take like much time. So binomial. Now, what is the meaning of binomial distribution function, guys? So there are like certain assumptions. There are certain assumptions which help us to understand that this particular question or this particular values. These values are belonging to a binomial distribution. Okay, so very first thing that whenever in case of binomial distribution, we are always going to talk about a discrete random variable. Okay, so we are not going to talk about a continuous random variable. We are always going to talk about a discrete random variable in case of a binomial distribution function. Okay, in case of a binomial distribution. Okay, now there are certain assumptions of a binomial distribution. So like the experiment. Okay, so in case of a binomial distribution, each trial. Okay, so each trial. Okay, so means suppose if I ask you to toss a coin maybe n number of times. Okay, so that n number of times means maybe if you are trying to n, suppose your n is equals to 10, it means you are trying you are like then a number of trials is equals to what? Number of trials is equals to 10. Okay, so your trials should be independent. Okay, So the trial is independent. Okay, so the trial should be independent. So this is a very the first assumption of a binomial distribution. And the second most important assumption is each trial has only two possible outcomes. Okay, so whether it is a failure or whether it is a success or whether it is a failure. Okay, so each trial should have only have like two possible outcomes, denoted as success or failure. Okay, so whether it will be a success or whether it will be a failure, nothing like else. Fine. So this is a meaning of a binomial distribution. So this is what happened in case of a binomial distribution. And even if you like understand the formula for the binomial distribution, so this is how we are able to find out the probability of any event associated with the binomial distribution. So P of X, so this is going to be like NCR P to the power R and Q to the power N minus R. Now this N is going to be nothing but this N is going to be a number of trial, okay, or like a total number of samples, you can say. Okay, so this N is nothing but it is going to be a like total like a number of samples, you can say, or number of trial, you can say. Then this R is nothing but like a success, number of success, you can see. Then this P is nothing but it is going to be a success rate. And this Q is nothing but it is going to be a failure rate. Okay, and even it can be also denoted as 1 minus P. Okay, and you can even try to break it. So this will become N minus R, and then a factorial R, then e to the power R, and then q to the power N. So yeah, even with the help of Python, you can like code this thing, like you can do this calculation in a just single line of a code. So that is not a big deal. The main thing is you need to understand the question and you need to you need to clearly identify what is N, what is R, what is P, what is Q. Now guys, so just for the clarification, if I ask you one question, so just try to like identify N, R, P and Q, and I think if you are able to understand, if you are able to identify, then we are good to go with the second probability distribution. Okay, so suppose if I ask you the question that what is the probability of getting 4 heads? Okay, what is, so just try to listen my question carefully. Okay, what is the probability of getting 4 heads if I toss a coin, if I toss a fair coin 10 times? Okay, what is the probability of getting 4 heads if I tossed a fair coin 4 times? Yeah, I think my question is clear to everyone. So anyone who is capable to give the answer of this question? You only need to tell me what is N, what is R, what is P, and what is Q. You only need to identify these 4 things. Okay. So I ask you that what is the probability? I will write this question over here. What is the probability of getting 4 head? Okay, of getting 4 head if I tossed the fair coin 10 times. Okay, now I think I clearly write the question over here. Now any one of you can identify N, R, P and Q clearly. Yeah, correct. So N is equals to 10, R is equals to 4. Yeah, completely correct. And Shri Vidya, what is P and Q in this case? Yeah, n is 10 and r should be 4. Yeah, correct. Correct, guys. Then what is p and q, guys? No. Okay. So in this case, the rate is already defined. Okay, so the rate is already defined because suppose if I ask you the question, okay, so I think someone written 4 upon 10. No, it is not 4 upon 10, guys. Suppose if I ask you the direct question, what is the probability of getting head if I toss like a coin? Okay, so the probability of getting a head or the probability of getting a tail is always going to be same. Okay, so success rate means what is the chances of your success. Okay, so if you toss a coin, so what is the chances of getting a head? That is your success rate. Okay, so the chances of getting head or the chances of getting tail is always will be what? 1 upon 2. That is not going to be changed at all. Yeah, not 1. 1 upon 2, guys. So your p is 1 upon 2, and if p is 1 upon 2, then q is also 1 upon 2. Okay, so n and you are able to identify n and r very clearly. Okay, so this is correct, but p is 1 upon 2 and q is 1 upon 2 because we know that whenever we toss a coin, so the success, okay, or the probability of getting any event, okay, so there are just two events, head or tail. Okay, so the probability of getting any event is always 1 upon 2. Okay, so that is why your success rate, so this is that is why it is here written as success rate. Okay, so this will always equals to 1 upon 2 in case of tossing a coin. Suppose if I change the question, if I replace the question with throwing a dice, then it becomes 1 upon 6 and the failure it become 5 upon 6. Okay, because if I ask you the question that if you throw a dice, then what is the probability of getting 5, or what is the probability of getting 3, or what is the probability of getting any number? So it should always be equals to what? 1 upon 6. Okay, so that's there your success rate is 1 upon 6 and failure rate is 1 minus 1 upon 6, that will be 5 upon 6. Okay, even we can plot a real time question, like a question from the real world scenario for this binomial distribution if you want to understand more clearly. Okay, so I rub this question from here. Okay, so I love this question from here because all the like a formula and the notations are written over here itself. So that is why I like rub this question and I will write a new question for you. Okay, so suppose in like some hospital, okay, suppose in one of the hospitals, so like at the time of corona or like right now also like omicron, so suppose there is one hospital where the death rate is very high. Okay, where the death rate is very high, so death rate is something like this. So if we admit, okay, so in that hospital, so that is like performance of that particular hospital. Okay, so this is the performance of that particular hospital, that if 100 patients, okay, so if suppose 100 patients are like admitted in the hospital, so out of this 100%, 75, like suppose like this 100% from like one particular disease. Okay, so maybe a corona, maybe omicron. So out of this 100%, 75 will die. So this is a kind of a rate. This is a kind of a ratio going on. This is a ratio for like that particular hospital. So there is one hospital where the ratio, where if the patient is admitted and he's suffering from corona, so out of 100%, 75 will die. So this is a kind of a ratio going on. This is a kind of a scenario going on. Now here my question is, what is the probability? What is the probability? So this just keep this ratio in your mind. Okay, and then try to answer this question. What is the probability? What is the probability that if I select or if I pick, if I select 6 people at random, then 4 of them will survive. Okay, so what is the probability that if I select 6 people at random, then 4 of them will survive? Okay, and this is a rate going on. This is a ratio going on. Okay, so in some hospital, out of 100%, so this is a kind of a ratio going on that out of 100% suffering from corona, 75 will die. Now, what is the probability that if I select 6 people at random, then 4 of them will survive? Okay, so now here just identify N, R, P, and Q. Okay, now this is a task, or this is a question from a real world scenario, and here you need to find out the probability by using. You can find out the probability only by using the binomial distribution. There is no other way. Okay, now use the binomial distribution in this real question, and then try to answer me. Just try to give me N, R, P, and Q, because if you are able to identify N, R, P, and Q correctly, definitely you are able to solve this, because you have a calculator. You are able to solve this thing. And even for this, like for this solution, you can use a Python code. That is not an issue. Okay, anyone else? I got one answer. Now, anyone else? Okay, I think, yeah, this answer is absolutely correct. Very good, Minakshi Abrirami. Okay, so this answer is absolutely correct. So your N will be a 6, because we select 6 people at random. So means my sample size is 6. R is 4, because a number of success is nothing but we want 4 people to people to survive. So R is 4, and our success depend upon the survival. Okay, so here if out of 100 75 will die, means how many people are able to survive? 25. So 0 upon 0.25. Okay, so P is nothing but 0.25, because 25% people will survive, and Q is already given, that is 0.75. Okay, so absolutely correct, absolutely genius. This answer is absolutely correct, and this will be your N, R, P, and Q. Guys, I think now all of you are able to understand the binomial distribution. Okay, and this is how you can use the binomial distribution in a real world scenario. Okay, guys. Fine. Anyone having any doubt regarding this? Okay. Now, come on to the second distribution. Okay, we can take at last. Okay, even we don't need like another example, guys. It will take only your time. Okay, we need to discuss a lot of things. So just try to replace the last question with throwing a dice. Okay, so just try to replace this question with throwing a dice. What is the probability of? Okay, so suppose if I ask that, what is the probability of getting 2 5? Okay, 2 5. Okay, so means 5 2 times. If I throw a dice, maybe 10 times. So just do this question. Okay, what is the probability of getting 2 5 if I throw a dice 10 times? Okay, give your N, R, P, and Q. Okay, guys, now come on to the Poisson distribution. Now, each assumption of a Poisson distribution is again going to be same. Okay, so even this is also a discrete distribution. So just like binomial, this is also a discrete distribution, and even each occurrence is independent of other occurrence, means like each event should be independent. Okay, so these two assumption is like a same in both the scenario, in case of a Poisson and in case of a binomial. This two assumption is same. Now the main thing which is like a difference, which make a difference between like a binomial and Poisson, that this is like it describes the discrete occurrences over an interval. Okay, so in case of a Poisson distribution, we are always trying to find out the probability in terms of an interval. Okay, in terms of like per interval. Okay, so this is what a meaning of a Poisson distribution. Okay, so in case of a Poisson distribution, we are always trying to find out a probability in some interval. Okay, so we are always trying to find the occurrences of an event with respect to some interval. Okay, so it may be like per hour, it may be per day, it may be per minute, it may be like yeah, per length, or yeah, like anything, anything. Okay, or like per accidents. So with respect to some intervals, so we are also trying to find out the occurrence of any event with respect to some interval. So that is what that is what like main thing in a Poisson distribution. Okay, and if I like try to write a PDF for this distribution, so the PDF for this distribution is going to be nothing but e to the power mu to the power x divided by x factorial. Now this mu is nothing but average value, mean. So I think we already know that this mu is nothing but a mean. And yeah, so suppose if I can give you an example. So suppose there is some road. Okay, so there is one road where accidents occur, accidents occur in a regular interval. Okay, so some kind of a road maybe are there where the accidents occur in a regular interval. Fine. Now, what happened if I ask you the question that what is the probability that in next so suppose it is having like a scenario. Okay, so just like in a previous case, in case of a binomial distribution, we take one scenario. So suppose there is one road where on an average in every 10 hours 2 accidents occur. Okay, so on an average in every 10 hours 2 accidents occur. So this is like a scenario. This is a kind of a ratio which is going on from very long time in like maybe one highway, that in every 10 hours 2 accidents will occur. 2 accidents occurred. Okay, now if I ask you the question that what is the probability that in next 20 hours, what is the probability that in next 20 hours only one accident will occur? Okay, what is the probability that in next 20 hours only one accident will occur? Okay, so now this is the question where you need to use a Poisson distribution. Okay, this is the question where you need to apply the formula for a Poisson distribution. We need to apply like this function to find out the probability. Okay, so just take like one question, guys, and just try to understand with this like question. So suppose you are a salesperson. Okay, or suppose there is any like salesperson who is having a record, who is having a kind of a record from a very longer time. He's working as a salesperson. A salesperson, you can think of anyone who is maybe there are a lot of products like Amway, and then like Patanjali, Ayurveda, Mama Earth. So there are a lot of products, and each products have their agents. So they go like home to home, and then they sell their products. Even you can think of LIC agents. Okay, so any kind of a premium. So LIC, or maybe there are a lot of premium things are there. So there are you can think of any agent who is selling their policies. Okay, you can sell the policies. Okay, so there is one salesperson who is having a record of selling who is having a record of selling 3 policies. Okay, on an average he's able to sell 3 policies in a week. Okay, so from a very long time, so maybe he's working as a he's working as a LIC agent maybe from last 2 years, and from last 2 years he's having this record that is able to sell 3 policies in a week. Okay, on an average he's able to sell 3 policies per week. So now here also we have like some interval. So definitely we are going to use a Poisson. Now, what is the probability? Now, if I ask you the question, what is the probability that in the next week in the next week, he is not able to sell. He is not able to sell single insurance, single policy. So he's not able to sell a single policy. Okay, what is the probability of this? So just try to identify X and mu in this case. Okay, because you need not to identify anything else. E is 2.72 a fixed value, and you need to identify mu and X. So what is X and mu in this case, guys? I think this is like a simplest question, guys. Not able to sell any insurance policy. What is the probability that he's not able to sell us any insurance policy in the next week? And his score is like a record is of selling 3 policies per week. So he's able to sell 3 policies per week. Now just try to give me the probability for like this thing. Guys, I think it's very simple question here. On an average, 3 insurance policies per week. So your mu is what? 3? Yeah, very correct. Again, mean is 3 and X is 0. Okay, so he's not able to sell any insurance policy. So X is what? 0. Oh, and mistake. Okay, so by mistake, I already write like mu. So mu is nothing but 3. Now you put like values over here and you will get like answer. So 3 to power 0 and 0 to factorial. Okay, how you get 3 upon 7, man? And how you get 1? I said no, not a single insurance policy. Okay, so X will be 0 and mu will be 3. So this number is already given over here. Okay. Okay, so this Poisson distribution is clear to everyone, or should I take one more example to make you understand? Okay, so now come on to the next array here. Okay, so just like take one more example. So suppose you are a writer. Okay, you are a writer, and or not you are not a writer. Maybe you are a researcher. You are writing a research paper on a daily basis, on a like on a regular interval. You are trying to write a research paper. Now, so on an average, you make a mistake of 1.5 unit. You always make a mistake of 1.5 unit per 100 pages. Okay, sorry, per 100 words. Okay, so in per 100 words you make a mistake of 1.5 unit. So this is your this is your record. So this is this is a claim you are making, like from a very long time you are working as a researcher and you are writing a research paper by your own. Okay, so on an average you always make a mistake of 1.5 unit per 100 per 100 words. Okay, so on like per 100 words you are going to make a mistake of 1.5 unit. Okay, this thing is clear. Now what is the probability, that you are not going to make a single mistake for next 400 pages? Okay, so just try to understand, like listen my question again carefully, that as a researcher, this is your habit, that you always make a mistake of 1.5 unit per 100 words. Okay, so at a time of writing a research paper, you always make a mistake of 1.5 unit per 100 words. Now what is the probability that you are not going to commit a single mistake for next 400 pages? Okay, so give me a mu and X for this question. What should be a mu and what should be the X? Good, guys. I think X is very simple again. You only need to find out the mean. Yeah, X is 0, correct. And mean is 6. Yeah, good guys. So mean is 6 because on an average you make a mistake of 1.5 unit per 100 pages. So now you need to I ask you the question for 400 pages. So 1.5 into 4, that is 6, and mu is 0. Sorry, X is 0 because I'm trying to find out the probability where you are not making a single mistake. Okay, guys, good. Now come on to the next thing, next distribution, that is a uniform distribution. Uniform distribution. Now this uniform distribution, even called you can even call it as a rectangular distribution. Okay. So now what is the like idea of a uniform distribution? So guys, just try to understand an idea, because the whatever the question may be anyone asks, so that question will be totally a formula based. Okay, so just try to understand the concept of a uniform distribution. And yeah, now there is a change that this is a continuous random variable. Okay, so this is a continuous distribution. Okay, so this is based on a continuous random variable. Now suppose here we have like 26 people, or not. I am not taking like this participant because maybe you got like angry or something. Okay, so I'm taking a general criteria. Okay, so maybe like someone asked me to conduct a survey and just try to take like weights of a person in the age group of 25 to 35. Okay, so in between the age group of 25 to 35, try to collect the weights of a person. Okay, now now if so suppose I will get an like weights such as maybe a minimum weight as 40, okay, and a maximum weight as 100. Okay, so maybe I got a like sorry, minimum weight as 50 and maximum weight as 100. Okay, so I think we can like suppose this much of one weight for this age group. Okay, for the age group of 25 to 35, we can we can thought of like this much of an weight. Okay, now what is an idea, what is the concept of a uniform distribution? So in case of uniform distribution, what happens? So here we are having a like, this is based on a continuous random variable. So here we can have a like my values in this way, and definitely in between we have like we definitely have a lot of values. So we may have a 50.5, 50.25, 51.25, any value, because weights can be weights are available in a in a decimals also. Okay, now okay, so now this is so in case of uniform distribution, guys, what happened in case of a uniform distribution? So if I got equal probability, okay, so if I got a equal number of people for each weight, okay, so for each weight, so suppose for each weight, if I got a equal number of people, then it is called a uniform distribution. Okay, so this is a very hypothetical thing. This is a very hypothetical thing. This is not possible at all. But suppose by default, so suppose if I got equal number of people for each weight. Okay, so for a 50, I got like suppose there are 5 people whose weight is 50. There are like again 5 people whose weight is 55. There are again 5 people whose weight is maybe 50.5. Okay, so if I got a equal number of person for each weight or for each value on the x-axis, okay, so it means that we got equal probabilities for each value. Okay, so we got equal probabilities on for each value on the x-axis. Okay, so this kind of a distribution is called a uniform distribution. Okay, guys, this idea is clear to you. And the probability distribution function, a PDF for the uniform distribution, is nothing but this is going to be f of x is 1 upon b minus a. Now this b minus a is nothing but this is the highest value b and this is the lowest value a, so b minus a. Okay, for all for all a is lesser than x is lesser than b. Okay, so this is my f of x. Okay, fine. And the area inside this curve, the area inside this curve will always equals to 1. Okay, so this should be always equals to 1. Fine. Okay. Now, just okay. So this is with respect to a uniform distribution. So the idea of uniform distribution, I think, is very easy to understand. That if the probability for each value, okay, so if the probability for each value on the x-axis is same, then it is called a uniform distribution. Okay. Now come on to the next distribution, which is called a normal or Gaussian distribution. Okay, normal or Gaussian distribution. Fine. Now, what is a normal distribution? Okay, so I'm going to take a same idea. Okay, so I'm going to take a like similar idea and like a same example, weight example, but this time we are going to talk about a normal distribution. Okay, so guys, even the like as the name suggests, okay, as the name like suggests, a normal distribution means even this entire world. Okay, so whatever the data we are going to take from this entire world, 95 or even 90% of the data is a normally distributed. Okay, so normally distributed means where we are trying to where my data set is trying to follow the general phenomena, okay, or general scenario, okay, where you are trying to represent the general scenario. Now if I ask you the question, okay, so suppose if I ask you the question that I give you the task that try to conduct a survey and try to take the weights of a person who says in between 25 to 35, and then if I ask you that what do you think, okay, so suppose if I ask you that what do you think that in this age group, what probably the weight of the person, okay, what probably the weight of the people. Okay, so I think every one of you is able to answer that most of the people will going to lie in between maybe a 60 to 80. Okay, so the weights of most of the person will going to lie in between 60 to 80. Okay, because so according to BMI, according to a body mass index, if your age is maybe in between 25 to 35, so definitely your height will be more than a 5.2 or maybe more than or equal to 5.2. So at that point of a time, your weight should be in between 60 to 80 if you are heavy, if you are healthy. Okay, so if I talking about a general phenomena, if I talk in a general sense, a normal tendency, so in a normal graph most of the people will lie in between 60 to 80. Okay, and that is why we are able to build this kind of a graph, this kind of a curve, and this is what we call a bell shaped curve. So this is called a bell shaped curve. Okay, so this is a bell shaped curve. And if you are having like if your data is normally distributed, so always remember guys, if your data is normally distributed, okay, so your mean median mode is going to be same. Okay, so your mean median mode is going to be same, or even you can say like a mean is 0, and yeah, definitely sorry, mean should not, so mean median mode is going to be the same. And so suppose your mean is maybe 70. Okay, so most of the people is having a weight maybe a 70, and then as I told you that the weight maybe okay, so even I think yesterday itself we like make this kind of a curve. If you remember, yesterday itself we make this kind of a curve where we we talked that Okay, so there are like few people whose weight may be like 40. Okay, there are like few people whose weight may be a 40, and there are few people whose weight may be 120. Okay, so like I can write over here a 40, then maybe a 45, then a 50, then a 55, then a 85, then a 95, then a 110, a 150, and 120. Okay, so there are very few people whose weight may be 115 and 120, and there are very few people whose weight may be 40 to 45. And but yeah, most of the people, 68% of the people will fall in this region where the weight is in between 60 to 80. Okay, and maybe my mu is 68, 95, 99 rule. Okay, empirical formula, if you remember. Yeah. So this is what we call a normal distribution, a Gaussian distribution. Okay. So in case of a Gaussian distribution, this is what going to happen. 68% of the data will lie in a mu plus minus standard deviation. Okay. So if you remember, so suppose my mu is 70 and my standard deviation is 10. So mu plus minus standard one standard deviation, you 68% of the data will lie. Okay. So if you remember, we discussed this thing in a last session, yesterday's session. Okay, and my formula will be my PDF. Okay, my PDF for this Gaussian distribution will be 1 upon sigma under root 2 pi e to the power minus x minus mu whole square, okay, divided by 2 sigma square. Okay, so now I think every one of you know that mu is nothing but mean, sigma is nothing but standard deviation, and this x is nothing but like the value for which we are going to find out the probability. So suppose I ask you that find out the probability, try to find out the probability of the weight 55, okay, or maybe a 65. So x will be your 65. Okay, so this is a formula for a Gaussian distribution. This is a formula for a normal distribution. This is a like PDF for the normal distribution. Okay, and this is what happened in case of a normal distribution. So you are always going to get a bell-shaped curve. Okay, you're always going to get a bell-shaped curve, and even 90 to 95% of the entire like whatever the data set you are getting from the entire population will lie in this region. And even in most of the cases, in most of the even like machine learning algorithm, whenever we are trying to build any kind of a machine learning model, so in most of the places, if my data set is not a normalized, okay, if my data set is not normalized, or if it is not follow the normal distribution curve, so we try to make it a normal distribution. Okay, so we try to we forcefully try to follow like that data to follow the normal distribution curve, or normalize that data, you can say. Okay, so even there is like two very important concept. There is two very important concepts which is like very much important even from the machine learning point of view. That is called a normalization and standardization. Okay, so what do you mean by a normalization, and even like what is the main idea, or what we are trying to achieve with this normalization? So with the help of normalization, we are always trying to bring all of my data into the similar scale. Okay, so what is the meaning of bringing all of my data into the similar scale? So guys, this is what going to happen. So suppose whenever we are trying to collect a data, whenever we are trying to collect information from the real world, so my data can be like in different format. Okay, my data can be like available in a different scales. Okay, so it may possible that some of the values are maybe I think yesterday itself we have discussed about the outlier. Okay, so it may possible that some of the values are available maybe 1, 2, 3, 4 in this way, and then there are some values maybe like 100, 200, 1,000, 10,000 in that way. Okay, so in a same data set, my data may be available in a different scales. Okay, maybe in a scale of 1, in in maybe scale of 100, in maybe scale of 1,000. So it is definitely possible that my data can available in a different scale. So to bring my data onto the same scale, we use this concept normalization and standardization. Now, by using this technique normalization, we are able to bring all of my data. We are able to bring all of my data in between a 0 to 1. Okay, so we are able to bring all of my data in in between 0 to 1. Okay, and this is the formula for normalization. Okay, so if we want to like perform the normalization, so this is the formula for normalization. So x minus x mean divided by x max minus x mean. Okay, so this is the formula for normalization. Okay, guys. Yeah, and even there are like different way. Okay, so even in a machine learning, like we are trying to check whether my data set is is in the form of a Gaussian distribution or not. And if it's not like Gaussian distribution, so we are trying to like perform a different techniques also. We are trying to use different techniques also to bring it on a Gaussian distribution plane, to bring it on a Gaussian distribution table. So we are even using a like something called a QQ plot. Okay, so you can try to search for it. So we can try to do like something called a QQ plot and then try to check whether my data set is normally distributed or not. And if it is not, then we are trying to make a Gaussian transformation. That is what we call a Gaussian transformation. Okay, and to make that thing possible, even we can try like some more mathematical techniques, some different mathematical technique also. Okay, so even this technique is one of the this technique is one of the technique to bring my data onto the similar scale. Even suppose if I ask you the question that you have like two values 1 and 100, and yeah, there is a huge difference between these two numbers 99. So normally, just in a normal sense, if I ask you that mathematically how you can minimize this difference. Okay, so if I ask you the very simple question that how you guys are able to minimize this difference, so what you can do to like minimize this difference, so you can take a square root even on the both side. Okay, and yeah, now the distance is like minimized, and again we can try to like take the square root. Okay, and now after taking this like double square root, this distance is even more minimized. Okay, and now even we are able to bring my data onto the similar scale. Okay, so this like QQ plot is able to make this like a generalization. Okay, so whether we are able to like bring my data onto the similar scale or not, whether we are able to make this as a Gaussian distribution or not. Okay, so with the help of QQ plot we can check this. So even you can perform a logarithmic transformation, a reciprocal transformation, exponential transformation, and this is what we call a square root transformation. So any technique you can take to bring my data onto the Gaussian distribution plane. Okay, and this is like one of the standard technique. This is one of the standard technique. Okay, guys. But yeah, this is the thing which we always trying to achieve. We always trying to bring all of my data onto the same scale, or you can specifically say on the Gaussian distribution plane. Okay, fine. Now the next distribution, or even you can say the last distribution, is nothing but a standard normal distribution. Okay, now what is the meaning of like standard normal distribution, guys? And or even it is even we are trying to perform a standardization also. So even the same concept is going to use for the purpose of standardization. Okay, so now what we are trying to do in case of a standardization. Okay, so what we are trying to do, guys, so after a standardization, after performing a standardization on my data set, what we are able to achieve, so we are able to achieve such kind of a distribution. We are able to achieve such kind of a distribution where my mean of becomes 0 and my standard deviation becomes 1. Okay, so after performing a standardization, okay, so after like you are trying to change the scale. Okay, you are trying to change the scale. So even here also you are trying to bring all of your data into the same scale. But in this case, what happened? You are able to make such kind of a distribution, or you are able to shift your distribution into a different plane, where your mu becomes 0 and standard deviation becomes 1. Okay, now try to understand this thing with an example. So suppose I'm having like this data set. Okay, maybe I'm having this like guys data set 1 1 2 3 4 2 5 7. Okay, guys, just try to find out a mu for this data set. What is a mu for like this data set? Right? What is the mu for this data set? Okay, this should not be a 0. This should be some value. Okay, what is this value? So 1 plus 1 is 2, 2 plus 2 is 4, 4 plus 3 is 7, 7 plus 4 is 11, 11 plus 2 is 13, 13 plus 5 is 18, 18 plus 7 is 25. So 1, 2, 3, 4, 5, 6, 7, 8. So 25 divided by 8 is going to be a 3.25 again. Okay, so my mu is nothing but a 3.25. Now my idea is to shift this distribution. So we want to like shift this like the same distribution in such a way. So we want to like make like kind of a shifting in such a way. Okay, so we want perform a kind of a shifting in such a way that my mu will become 0. Okay, so if we here we have a 3.25, then definitely here we have a 0. So we want to make a like kind of a shifting. We want to like make this kind of a shifting through which my mu becomes 0. Okay, now to make this thing possible, what we are going to do? So we are going to like take this formula. Okay, so this is a formula through which you can perform a standardization. X minus mu upon sigma. So this is a formula through which you are able to perform an standardization. Okay, x minus mu upon sigma. Okay, and now guys, you can do this thing and you can see that you are able to get a new distribution. And for new distribution, if you are trying to find out a mu and sigma, so your mu and sigma for this new distribution will become 0 and a sigma will become 1. Okay, so x is what? 1, mu is 3.25, sigma may be 2. So if you make this a calculation, so you will get some value over here with this like in corresponding to this 1. Then again for this one, again you get some value. Then for 2 again you get another value, 3 again. So you will get a new distribution over here, a new data set over here. And for this new data set, if you are trying to find out a mu, so definitely you are able to get 0. And if you're trying to find out a sigma, so you are able to get 1. Okay, so you can do this calculation and you can cross check like my statement. Okay, and this is what a meaning of a standardization. So in case of a standardization, we shift our distribution in such a way that the mu for this the new for this new distribution will become 0 and the standard deviation for this new distribution will become 1. Okay, and this is an idea of for a standardization. And here in this case, my whole value, so like in this case the whole value is in between 0 to 1 in case of normalization. So in case of a standardization, the whole value means the value on the x-axis is going to be in between minus 3.4 to plus 3.4. Okay. Oh, sorry, bhai. 3.125. Okay. I don't think that it makes any difference over here, but yeah, sorry. Right. So guys, you are able to understand like this concept of a normalization and standardization. I didn't understand what you want to ask. Always question mark means. Yeah, minus 3.4 to plus 3.4 always. Okay, in some book you are able to see maybe minus 4 to 4, but standard value is minus 3.4 to plus 3.4. Okay, or you like the distribution. Okay, so the main concept of standardization and normalization is to bring my data onto the same scale. So if it is even minus 4 to plus 4, then also it is on the same scale, and if it is minus 3.4 to plus 3.4, then also it is on the same scale. Okay, so no matter whether it is 3.4 to whether it is 3.4 or whether it is 4, the main idea we are able to achieve, the main thing which we are able to achieve is bring my data onto the same scale. Okay, in two different ways. One is normalization, another one is standardization. Okay, guys. Okay, so this is this is these are all the things in this a probability distribution. Okay, so these are all from this probability distribution. Now the next thing which we need to like understand in case of you can say with respect to statistics and probability is nothing but hypothesis testing. Okay, so hypothesis testing, as I told you, we are trying to do a hypothesis testing to check the credibility of our claim. Okay, to check the credibility of our claim, that whether whatever the claim we are making for an inferential statistics, whatever the claim we are making for a population, based on the information we get from the sample, whether this information is correct or whether this claim is correct or not. Okay, so we want to check the credibility of our claim. So we can check the credibility of our claim with the help of hypothesis testing. Okay, but before start the hypothesis testing, as I told you, and we are included like this thing in our curriculum also, that we also learn like Python. Okay, so now in next 1 hour I will going to teach you like some basics of Python. Okay, some basic concepts of Python. Okay, so guys, just like give me a break of 3 to 4 minutes. I will drink some water, and then we are going to shift on the Python. Okay, for today and now. Okay. Okay, guys. So it's you can even if you want, you can try to code on your local system. But I don't know that how many of you are using your local system. That how many of you are like install this thing on your like local system. Okay, even the link I shared the link with you in like yesterday's session. But yeah, it is fine if you're not like install those things. Okay, one second. So this is a data science band. So this is how you can like try to do this thing on your drive also. Okay, so you can go onto the your Google Drive. Okay, and there you can try to like create your like folder. Okay, so you can try to like create one folder. Okay, as I created one over here. Then inside this you can make a right click. Okay, so this is like a simplest way of do the like do this coding. Okay, if you're not having a Python or Anaconda in your local system, so if you're not having like those systems or those things stored in your local system, so you can simply go onto the your drive and you can create a new folder, and inside that new folder you can start coding it along with me also right now on a Google Collaboratory. Okay, so there is something called a Google Collaboratory. So you can try to code on a Google Collaboratory even. Okay, so maybe you are using this thing. You are going to use this thing for the first time. You are going to use this Collaboratory for the first time. So even you can need to like maybe you are not able to find Google Collaboratory over here. So after clicking on this more, maybe you are not able to find like Google Collaboratory over here. So what you can try to do, you can try to click on the connect more apps. Okay, why no, I asked you to open the Google, your Google Drive. Okay, you definitely have an access of your Google Drive, na? Okay, so I asked you to open your Google Drive. Oh, in office you they don't allow to use URL. Okay, okay then. So you can code on the Jupyter notebook then. Yeah. So I'm telling the simplest way. If like because many of you didn't install it, so I'm telling you the simplest way. So you can click on the collect more apps, and if you click on the collect more apps, so you are able to see this kind of a box. And here you can go on to the search and click write a collaboratory. Okay, so in a search you can write a collaboratory, and you are able to find a collaboratory over here. So in my system it is already installed. In your system you can click on the install and it will install in a second. Okay, and after the installation again when you click on this more, you are definitely able to find this collaboratory. Okay, and now then this a notebook kind of a thing is you are able to see in front of you. This is a kind of a Jupyter notebook. Okay, so this is the same thing which you are able to find if you are trying to code after the installation of Anaconda and Python and all. Okay, so now this is a Google collaboratory for you guys, and here we can start our code. So maybe a Python basics. I can start with the Python basics. So guys, in a Python, so Python is like a simplest language existing on like this planet in terms of a complexity. Okay, so because it is Python is a very less complex. Okay, in like in terms of complexity, Python is not even complex at all. Okay, so in terms of complexity, suppose if I give a rating to a C++ Java, and then if I make a comparison with a Python, so maybe if maybe I can give I can give one rate of in terms of a complexity to the Python. Okay, so and even you can make this thing, you verify this thing from here also. So in a Python you need not to you need not to code all the header files, So you need not to like you need not to follow all the protocols as you are trying to follow in case of a C++ or Java. Okay, so here suppose if you want to print a hello world, so simply you can try to write print, and then in a bracket you can like write hello and a word, and you are able to print your statement. Okay, so this is a hello world, guys. Okay, so I will increase this thing. Fine. Now there are 6 data types in Python. Okay, so I will teach you only these six data types because the rest of the things are fine. We only need to know the basics for now. So there are 6 data types in Python, and those 6 data types are nothing but string, numbers, list, tuple, dictionary, and sets. Okay, so there are 6 different data types, and like in case of a Python, we need not to tell like a compiler that which type of data is this. Okay, so there are 6 data types, and Python is able to recognize that kind of like type of a data just with their signature. Okay, so every data type has their like their own signature. Okay, so suppose if you want to write a string, okay, so if you want to represent anything in a string, so in a Python, if you write anything in a single quote or double quote, okay, so suppose if I write anything in a single quote or double quote, then it becomes a string. Okay, so suppose if I write maybe a Shivam Singh over here, now this is a string, and Python is able to recognize. Okay, now this S is what? S is nothing but a variable. Okay, so S is nothing but a variable. So variable means what? A variable is an address for any kind of a data. Okay, so whatever the data we want to store, we want to like we can store in any variable, and variable is nothing but an address. Okay, so it acts as a nameplate. Okay, so like all we are having like a nameplate in front of like in our gate. Okay, so that is a that actually helps us to get the address of that particular person. Okay, so variable is acting as an address. Okay, now if I want to check the type of S, so I can write type and S, so str. Okay, so anything which is, maybe if I write like any number over here. Okay, so if I write like maybe any number over here, then also it is a string because it is written in a double quote. If I write this thing in a single quote, then also it is a string. Okay, so yeah, guys, this is how Python is able to recognize, okay, whether it is a string or whether it is a like a number. Right? Yeah. Now, okay, so in a string, okay, in a string, even we can do indexing. Okay, so suppose we are having like this kind of a string. Okay, so suppose I'm having like Shivam Singh over here. Now I can perform indexing. So like all these values is stored in a heap memory. Okay, so all this SHIVAM, then space, then SINGH is stored in a heap memory in form of all these are like characters. Okay, so all these characters are stored in a heap memory in a form of an array. Okay, so these things are stored in form of an array in a heap memory. Okay, so this is how they are represented in in a heap memory. So let me tell you. Okay, oh Ruby ma'am, you guys remove the annotation from here, I think. Okay, so let me. Okay, so in form of an array. Okay, so it is an array now. So you are having S H I V A M, then we are having any space I N G and then H. So, and this is how we can do the indexing. So 0 1 2 3 4 5 6 7 8 9 10 and 11. Okay, so and this is what this is equals to, A is equals to this. Okay, now So this is how we can do the indexing. Okay, so now indexing will help us to like access any character. Okay, so suppose if I want to access any character, so suppose if I want to access maybe I, okay, if I sorry if I want to access maybe this V, so what is the index value of V? So the index value of V is nothing but a 0 1 2 3. So from like if I write 3 over here, so I'm able to access V. Okay, yeah, indexing is same as Java. Fine. So this is how you can do the indexing. So and there are like different like properties. There are a lot of like a lot of properties, or you can say a lot of built-in functions. Okay, even you can call it as a built-in functions associated with each data type. Okay, not only the string, associated with each data type. Okay, so suppose if I want to find the length of a string. Okay, so if I want to find the length of a string, so for that, what I can do, I can use this like function len. So len is again a built-in function, and then I can pass my variable over here a, and it will give you the like the length of this variable. Okay, so the length of this like Shivam saying is nothing but 12. Okay, so even you can try to cross check it. You can try to count. Okay, then there are yeah, there are another function also. So suppose if I'm having this, if I'm like suppose if I'm having my character in this way. Okay, so maybe a Shivam Singh. Okay, now there is like two important built-in method. Okay, and even if you can see, so there are like these are all built-in methods which are available, but we need not to use all. We can use only like we are using maybe only 3 or 4 in our daily basis. So there is one method called capitalize. Okay, so there is one method called a capitalize. Okay, and then there is one method which is called a title. Okay, there is one method called a title. Now just try to understand the significance and understand the difference between these two. So in case of capitalize, only the first letter, okay, only the first letter of your statement or you can say of your word become capital. Okay, and in case of title, each letter, the first letter of each word become is capital. Okay, so this is what happened in case. This is what are like a difference between a capitalize and title. Okay, so suppose if you're writing a paragraph. Okay, so suppose here we have like inside this C, maybe we are having a paragraph. Okay, so we can use a capitalize option because it will like capitalize only the first character of the first word. Okay, and in case of a title, so suppose you are having like a lot of country name, like there is a country name, okay, written, or maybe a name of any person. So in case, so just like in this case, we are, this is a name of any person. So we want the name or also the first word of any person name should be a capital. Okay, so there you can use a title. Okay, so both so there are like two functions, both are like doing the same thing but in a different way. Okay, and that is why there are like a different significance. There are different like a purpose you can where you can use like a title, and there are like different purpose where you can use a capitalize. Okay, then there are a lot of functions you can try to use like a lower. So lower for lowering the character. So so my like this Shivam Singh is already in lowercase character, so you can try to use upper. Okay, so now all the characters are converted to the uppercase character. Okay, so these are all the functions. Okay, so there are a lot of Boolean functions are available. So if you try to check is maybe a lower. Okay, so yeah, all the characters are in the lowercase character, so you will get true over here. If you write is upper, so all the characters are lower in lowercase characters, so that is why you will get a false over here. Okay, so we will get a Boolean output over here. Fine. So yeah, these are all the functions which we can try to use okay from the string. Then the second data type is nothing but a numbers. Okay, so second data type is nothing but a numbers. Now number is again very easy to understand. So if I try to write any number without a single quote or double quote, so Python is able to understand. So this is nothing but an integer or maybe a decimal, but yeah, this is not, so it is able to understand. Okay, so if I write anything without any decimal value, so it is able to understand this is an integer. If I write anything with a decimal value, so Python is able to understand this is a floating point integer. Even if I write anything in maybe in form of a real and imaginary number. Okay, so I think you know that there is one form of a number which is called a complex number. Okay, so complex number is always represented in a in form of a real and imaginary form. Okay, so that is what we call a complex number. So suppose we are having a like this number, maybe a 2 plus okay, so first start with the numbers. Okay, so suppose I'm having like n is equals to 3. Now if I check the type of this n, so yeah, integer. If I make it 3.7, so I think it is able to understand float. Now if I write like n is equals to 5 plus 7j, okay, and then if I try to write a type of n, so yeah, it is a complex number. Okay, and even you can perform any kind of arithmetic operation, not like any kind, but basic arithmetic operation, you can say, with the in integers directly. Okay, you need not to apply any maybe any function or anything to perform an arithmetic operation. So you can perform any like arithmetic operation directly. Okay, so suppose if I want to add two numbers, so yeah, that is possible. You can add two numbers. If you want to like subtract two numbers, so yeah, that is again possible, 9 minus 8. If you want to multiply two numbers, so yeah, it is possible. If you want to divide two numbers, so again it is possible. Okay, even if you want to get a power of any number, okay, so that is also possible. Okay, so if I try to write a 3, maybe if I want to find out the square root of 3, square of 3, so yeah, it is possible. Cube, so just write 3 over here, then you will be able to find out the cube. Okay, so a power is also possible in this like simple way. Fine. So that is why Python is very like easiest language to understand. Okay, even if you want to suppose if you don't want a remainder, okay, so here we have 1.125. Okay, so but you don't want a you don't want like a number after a decimal. So what you can do, you can try to divide in this way. Now you will get only a integer value. Okay? So yeah, I think it's very easy to understand. Now, one thing, guys, one thing you always need to remember that okay, you can't like apply any arithmetic operation, or you can't use any arithmetic operator in between two different data type. Okay, so I think till now we understand numbers and string. Okay, so there are like two data types which we are able to understand till now. One is like string, another one is number. But we can't apply, and even if we want to add like two strings, so that is possible. Okay, so suppose this is one string, and if I want to concatenate two strings, so yeah, it is like possible at all. But if I try to add maybe one number with another if I want to add one number and integer, okay, sorry, integer and a string, okay, so that is not possible. Okay, so suppose if you want to add like maybe a number and an integer, so there you need to do something called a typecasting. Okay, so for suppose there is one thing like a Shivam, and maybe Shivam's age is, and then after this I want to make addition operation, and maybe I write a 25. Okay, so this thing is not possible because this is an string and this is an integer. Okay, so this is not possible. But if I really want to add these two numbers, so what I need to do, I need to use something called a typecasting. So I need to convert this integer into a string. Now this addition is possible. Okay, So even I can like do this, I can do this thing in this way also. Yeah. So guys, these are like two basic data types in a Python. And then another four data types are nothing but a list, tuple, dictionary, and sets. Even you can call it as like these four data types is also like called as a data structures. Okay, because uh, we can try to take a multiple data type, multiple elements. We can try to make a collection. Okay, so inside a list, tuple, dictionary, and sets, we are trying to make a collection. We are trying to take a collections of a different like heterogeneous elements. Okay, so and there are based on a mutability and immutability, we can also make a differentiation. We can also make a difference between all these data types based on a mutability and immutability. Okay, now mutability means where we can make a change at any point of a time. Okay, so if my data type is mutable, it means that we can make any change, or we can update my variable, or we can update my maybe a list tuple. Okay, we can update my like data structure at any point of a time. Okay, so updating this thing is possible at any point of a time in case if it is a mutable. Okay, and we are not able to make a change, we are not able to update those things if it is immutable. Okay, so guys, just try to understand. So this tuple, list this tuple is immutable, and list and dictionary is mutable. Okay, so in a tuple, in case of tuple, you can't make a change, you can't like update at any point of a time. Okay, but in case of a list, you can update it, you can modify it at any point of a time. Okay, so let's start with the tuple first. Okay, because tuple is very easy to understand, and even a tuple is not having lot of functions. Okay, so it is like a very small in comparison with a list and dictionary. Okay, now how we can understand, how my Python compiler is able to understand that whatever the thing is written over here is a tuple. Okay, so if I have an element, okay, if I have a collection of a heterogeneous element inside a parenthesis. Okay, if I have a collection of an element inside a parenthesis, then it is called a tuple. Okay, so okay, so suppose I'm having like these numbers over here. And then I'm having maybe a 9 over here. So collection of heterogeneous elements. So guys, this so it means that we can have any data type. Okay, so we can have any data type inside this tuple. Okay, so we can have a like element of any data type. Okay, so here we are having an integer also, we are having a float point number also, floating also, and we are having a string also. Okay, now if I want to find out the type of this t, so the type of this T is the type of this T is nothing but a tuple. Okay, and here also you can perform indexing. So because all these elements is having some index value. Okay, because all these elements are stored somewhere in the heap memory in form of an array. So all these elements is having some index value. Okay, so suppose if I want to access maybe a 7 only. Okay, so the index value of 7 is nothing but 2. Okay, so we are able to get 7 over here. Fine. And now and even if you want to get the length of like this tuple, that how many elements are inside this tuple, so yeah, we can get the length. Fine. Now if I want to check maybe some more like a function, so it is having just two built-in functions. So it is not having a like lot of built-in function. We are having just two built-in function. One is count, another one is index. Okay, so count means if I want to make a count of any particular element. So maybe there is if I repeat some elements. Okay, so maybe if I repeat maybe a 7, and then I make like a repeat of 2. So now if I want to check that how many times 7 is present. Yeah, so I can get it. So 7 is present 3 times, right? And similarly, if I want to get the index of any particular element, okay, so suppose if I want to get the index of maybe 3.7, fine, you will get it. So 3.7 is present at third index value. Okay, so this is like a properties, or this is a kind of a built-in function associated with this tuple. And I think here you only need to understand, you only need to remember the concept of tuple. So tuple is nothing but it is a collection of heterogeneous element which is inside a inside a parenthesis. Okay, so collection of heterogeneous element inside a parenthesis, that is what we call a tuple. Now if I talk about a list, so how list is different from a tuple. So the definition is again same, but now this this time these heterogeneous elements are going to we are going to write this heterogeneous element inside a square bracket. Okay, so we are going to change the signature. Okay, so in case of tuple the elements are inside like parenthesis. Now in case of a list, all the elements should be inside a square bracket. Okay, so if I want to make a list over here, so I need to make a square bracket. Okay, so I'm having maybe these elements. Okay, so now this is a list, right? And if I want to get the index value of if I want to access any element, so I need to give the index value. Okay, so suppose if I want to access this 4.9, so the index value of this 4.9 is nothing but 3. Yeah, so I'm able to access it, right? And guys, just okay, there is one more difference. There is one very important difference in between a list and tuple. So tuple is immutable. Okay, it means you can't make any change, or you can't update it at any point of a time. So suppose maybe here I want to update this. Okay, so maybe here if I want to update this tuple. Okay, so just try to understand. So suppose here if I want to make a updation, so maybe in place of 4, okay, so maybe in place of 4 I want to make it as 40. Okay, so 4 is at first index value, so in place of 4 I want to make it as 40. So just check it whether it is possible or not. So if I try to do this thing, so it will give me an error. Okay, so what error I'm getting an error, type error, tuple object does not support item assignment. Okay, so it means that updation or modification at any point of a time is not possible in case of a tuple. Okay, now and that is why it is called a immutable. Okay, now try to perform the same thing with a list. Okay, so suppose in place of Python I want to make any number. Okay, so I want in place of Python I want to make it as 50. Okay, so what is the index value of Python, guys? So 0, 1, 2, 3 and 4. So index value of Python is nothing but 4, and here in place of Python I want to make it as 50. Now run it. So yeah, I am not getting any error, and even if I run this list again, so I will get a 50 over here. It means my list will update it, and in place of Python I am getting a 50 over here. Okay, so this is what happened in case of a list, and this and that is why it is called a mutable. Okay, because we can make a change, we can make and update at any point of a time. Fine, this is not possible in a tuple. Okay, now guys, just try to understand some like basic built-in methods which is inside a list. So suppose if you want to like add some numbers, okay. So if you want to add some numbers, so you can use a append. Okay, so suppose if you want to add some more elements, okay. So after this 12, if you want to add some more numbers, so yeah, that is possible. You can use append and you can give that a number. Even if you want to add any string, so that is also possible. So suppose if I want to add any number, maybe a 53, so yeah, 53 is added, and if I run this list again, so you can see 53 at last. Okay, so append means if you I can add any number at the last. Okay, or you can say I can add any element at the last. Fine. Okay, now if I try to write so append is there. Okay, I think count is having us is like the same thing as we are trying to do in case of like tuple. Now there is like one thing which is very important, insert function and extend function. Okay, so insert function and extend function is very important. So just try to understand the insert first, and then I will give you the the introduction for the extend function. So insert means, suppose if I want to insert any number in bit field. Okay, so if I want to insert any number at my at my specified index value. Okay, so at any index value, at any like any specified position, I want to insert any number. Okay, so maybe I'm not going to replace anything. Okay, I'm not going to replace anything. So I'm not going to just like we do the updation over here. So we are not going to do like that kind of updation or modification. So I'm not going to like replace any value. I just going to replace like shift the value. Okay, so suppose on the first index value, on the first index place, in place of 8, so I want to shift the 8 to the second index value, and in this place I want maybe any string. Okay, so I want any a string, maybe I want a like Shivam over here, and after that I want to shift all this value to n+1. Okay, so like the index value for 8 is nothing but 2, then it will shift to the third index value, it will shift to the fourth index value, in this way. Okay, so what I can try to do, I can try to write an index value over here. So at which index I want to insert my like number or my element. Okay, so I want to insert on the first index value, and then I can give a Shivam over here. Okay, now if I run L again, so yeah, Shivam is on the first index value. Okay, guys. Now just try to understand like a meaning of difference. So there is a difference between append and extend. Okay, so even in extend also we are trying to do the same thing. We are trying to add the elements, but we are able to add the elements in a different way. Okay, so just try to understand that how we are able to add the element in case of extend operation. So in case of extend operation, we can't add a single integer. Okay, we can't add a like a single element. Okay, we can extend. Okay, we can extend the list with the multiple elements. Okay, so just try to understand this thing. So we are having maybe this list over here, and then inside L2, I'm having like maybe this element. Okay. Now if I write L1 dot append L2, so guys just check what happened. So if I write L1 dot append L2, so I'm able to append like this like new list at last of the L1. Okay, so I'm able to it will create a nested list. Okay, so it will create a nested list over here. Okay, so it will create a nested list over here. So and that is why you can see that I'm getting this the whole list. The whole list is added at the last at the last of this like first list. Okay, so the whole list is like going is will be added at the last. Okay, now if I'm using the extend, okay, so in place of append, if I use the extend, so what happened? L2. Now this time you are able to see the different result. Okay, so my L1 list is extended with the element of the L2 list. Okay, so this is the difference between append and extend. So in case of append, a nested list will be created. Okay, so the nested list will be created. So we are able to end off creating the nested list. And in case of extend, no nested list is created. We are the elements of the new list. The element of the new list is added from the in the previous list. Okay, so in the existing list, the element of new list is added. Okay, so we are able to extend the same list. Okay, so we are going to extend the same list with the element of the new list. Okay, so this is what happened in case of an extend. Okay, in append we are creating a nested list. Okay, so this is a difference between append and extend. Now there are some more functions, guys. So there are like some more functions of like list, but these functions are quite easy to understand. So even you can try to understand by its own. So like there is a pop operation. So pop means nothing but if you want to delete any element. Okay, so pop means we are trying to delete from the last. Okay, so at last we are having an 11. Now if you run this L1 again, so you can see that 11 is deleted. Now there is one there is more functions. So in L1, if you are having you can see you have having a remove. Okay, so along with the pop we are having a remove over here. Okay, so in case of remove, you can give a you can give the element, which element you want to remove. You just name that element and that element will be removed. Okay, so suppose if I want to remove 98. Okay, so yeah, I'm able to remove the 98. You can see 98 will be removed. Now another operation. So if we want to reverse, so yeah, we can reverse this all these elements.
If there are more than 198, it will remove all 98.
Once again, what?
If you have more than 198 in the list, will it remove all 98?
All 90. Suppose if you are asking that if you are having more 98. Yeah, if it is removing with the name of the element, then definitely it needs to remove all the all the 98, or you can try to check it. Okay, so just check it here itself. Don't be in any confusion. Okay, so we are having L1. Okay, so is there any element which is repeated? 7, 2, 8, 9, 12. 12 is repeating 2 times, na? So just try to write 12 over here and check it. No, it is removing only the first element. Okay. Now, yeah, we can reverse the element. Fine. And at last, if you don't have to do anything, like I think we see all the functions. So what you can do, you can use the clear operation and you can remove all the elements from this L1. Okay, so this is yeah, these are all the things which you can try to perform with respect to a list. Okay, now another data type is nothing but a dictionary, or even this is also a data structure. Okay, now dictionary is again totally a different definition, you can say. Okay, so in case of a dictionary, elements are not stored in this manner. Okay, so in a manner we are trying to store the element in case of a tuple and list. So we can't store in a similar fashion. We can't store elements in a dictionary in a similar fashion. Okay, so in case of a dictionary, elements are always stored in form of a key value pair. Okay, so the elements are always stored in form of a key value pair inside a parenthesis. Okay, so sorry, inside a curly braces. Okay, so here we are going to use a curly braces, and these are the elements are going to be stored in form of a key and value pair. Okay, so now we are having like this dictionary over here, this curly braces over here. And now we are having like this key, and we are having like this pair. Sorry, key and value. Sorry. Okay. Now if I try to check the type of this this D, so yeah, this is nothing but a dictionary. Okay. So now I can make we can make a proper dictionary over here. So we can take like maybe a name of any student. Okay. So maybe a Shivam itself, then a registration number. Okay, then score. Okay, so maybe city. So this is my dictionary. This is my dictionary. Okay. Now if I want to access any value, okay, so if I want to access any value from this dictionary, so I can access. So now this time we can't access anything with the help of index value. Okay, so we can't access anything with the help of index value because there is no index value over there. So I can access any value with the help of a key name. Okay, so suppose if I want to access the score of Shivam, so I can access that score with the help of like key name. Yeah, so I'm getting an 89 over here. And even my dictionary is also a mutable data type. So if I want to make any change, or even if I want to update my dictionary, so yeah, we can update we can update the dictionary at any point of a time. Okay, so suppose if I want to like update this score. Okay, so suppose if I want to update this score, maybe if I want to make it as like 75. So yeah, possible. We can make this change. Fine. So this thing is possible, and even again dictionary is also having like some built-in methods. So we are having like a key. So suppose if you only want to see the keys of dictionary, so we can try to write keys over here. If I want to see like only the items of my dictionary, so I can try to write items over here. Okay, so item means both the things. So we are able to get key and value inside a list. Okay, inside the list and tuple. If I try to write d dot items, that is by mistake, right? You can write all the things into the single quote. You can write all the things into the double quote. That is not an issue. Okay, that is by mistake. I didn't write intensely. Okay, so don't worry about that thing. You can write this thing also into a single quote, or even you can write this thing into a double quote. Okay, so as I told you, a single quote or double quote is representation of what? String. Okay, so you can write. Now if I want to check only values, so yeah, this is possible. Okay, now if I want to update my dictionary, okay, so there is one option which is called an update. Okay, so update is important function. So suppose update is working in a similar way, just like extend is working in case of a list. Okay, so just like extend is working in case of a list, here update is working in a similar fashion. Okay, so suppose I'm having a new dictionary over here. So I'm having a new dictionary over here, and here I'm some more information about me. Okay, so maybe my zip code. Okay, so my zip code is maybe this, and maybe my like a telephone number. Okay, so that is maybe a 6. Okay, so now if I want to update this information in my existing dictionary, so yeah, I can make this this thing is possible. So we can use like a d dot update, and then I can try to write d2 over here. Now if you check my existing dictionary, so these two things are updated. Okay, so we have a telephone number and we have a zip code also, right? So this is how this is how we can update our dictionary. So even if you want to update the dictionary with some new information, so that is also possible. Fine. Okay, so these are all the things which you can do in with respect to a dictionary. Okay, so these are all the things which we can try to perform with respect to a dictionary. Now the last data type, or you can say a data structure, is nothing but a sets. Okay. Okay, so set the elements inside a set is again represented in a similar way. Okay, now the definition is little bit different. Okay, so the definition or even the concept is like different in with respect to a list tuple dictionary all. Okay, so in case of a list tuples, okay, so here we don't have, again we don't have like a key value pair. Okay, so we don't have like any kind of like a key value pair kind of a thing. Again we are going to store the elements, but this time the element is not a heterogeneous data type. Okay, so heterogeneous means we are able to store we are able to store maybe a string, float, integer, all the things at the same place. Okay, so that is why list and tuple is a collection of heterogeneous those are the collection of the heterogeneous data types. Okay, so the collection of heterogeneous data types. But now in case of sets, we can't do this thing. Okay, so this thing is not possible. So here we are going to store the elements, but all the elements should be all the same data type. Okay, so it is a collection of homogeneous data type. Okay, so this is the first difference. Second, here also all the elements are going to inside a curly braces. Okay, so just like a dictionary, but how Python is able to recognize whether it is a dictionary or whether it is a sets. So yeah, Python can easily recognize it. So suppose if I write any, so if I leave the blank curly braces, okay, so Python is recognize it as a dictionary. Okay, so Python recognize it as a dictionary. Okay, now if I make it if I fill it with a key and value pair, then it is again a dictionary. But suppose if I write any element, a single element or maybe a multiple element, so now it becomes a sets. It becomes a set. Okay, so this is the second thing. And the third very important thing which makes a set totally different from any other data type, and this is what the main purpose of set also. So set is a collection of homogeneous data type, or even you can say set is a collection of uniquely defined collection of uniquely defined homogeneous data type. It means that all the elements, okay, all the elements which are inside this set should be a unique. Okay, you can't repeat the element. Okay, we can't repeat the element. In case of a set, we can't repeat the element. Okay, so suppose, and even if we repeat it, it will always take a unique values only. And the second important thing, it will arrange it will automatically arrange your elements in ascending order. It means that it automatically sort your elements. Okay, it automatically sort your arrays elements. Okay, so suppose if I take elements in this way, so 6 7 2 1 1 6 8 9 3 2 2 7 4 40 12 4 2 1 9. Okay, so I think yeah, a lot of elements are repeated, and these elements are not sorted at all. Now if I run this, and if I again print s, so now we will get a sorted element, and you are able to get only the unique elements. Okay, so none of the elements are repeated over here. So this is the definition of set. So even you can, if you want, you can even try to write down that a set is an unordered collection data type. Okay, it is an unordered collection data type that is iterable, mutable, and has no duplicate elements. Okay, iterable, mutable, and has no duplicate element. Okay, so even it is a mutable also. Let me check, but I don't think so. Suppose if I want to access any maybe element, so I don't think I can even access it. Yes, it is not substitutable. Okay. So it's not mutable, it is iterable only. Okay, so yeah, you can write a set is an unordered collection data type that is iterable and has no duplicate element. Okay, that is iterable and sorted and has no duplicate element. right? So this is a definition you can write for sets. Okay, guys. So yeah, these are all the things. These are all the things which we can try to perform in this place. Okay, now I will show you like a very important thing which will which again brings us on the concept of statistics. Okay, so I think in yesterday's session we talk about the descriptive statistics. Okay, and suppose and we are doing those like calculation in our like notebook or maybe with the help of calculator. Suppose if you want to like perform those things in a Python code, so even with the help of Python code, those calculation it becomes super easy. Okay, so there is one library which is called a Numpy. Okay, Numpy stands for a numerical Python. Okay, so its name is a numerical Python. Okay, and it is used for a scientific notation. Okay, so sorry, scientific computation. Okay, so it's Numpy stands for a numerical Python and it is used for a scientific computation. Okay, now by using Numpy, and NP is nothing but an alias name. Okay, because everywhere we do, I don't want to write Numpy, so that is why I'm using an alias name as NP. Okay, now suppose I'm having this like data set, as we take like one data set yesterday also. So maybe I'm having like this data set. So 4 1 2 1, then like 3 5, then maybe a 6, then 2, then 3. Okay, so suppose this is my data set. Okay, now I want to find a mean of this data set. So how I'm able to find out this a mean of this data set? So np dot mean, and then I can pass my list over here. So the mean of this data set is nothing but 3, right? Even you can try to verify cross check this thing. Now the median of the data set. Okay, so how many elements are there, guys? So even you can try to calculate a median in here. And if I want to check the median, so median is nothing but, okay, so this should be a median, MED. So median is also 3. Now, if I want to check the mode, okay, Numpy has no attribute mode, fine, no issue. If I want to check something else, so suppose if I want to check maybe variance, 2.66. If I want to check standard deviation, that is also possible, 1.63. And if and guys, you can like cross verify all these values. You can cross check all these values and you will definitely get the similar answer. Okay, and there is one more thing, guys, IQR. So yesterday we talked about an outlier, that how we can identify an outlier. There is one more thing which is called an extreme outlier. So that extreme outlier we can identify, we can like get with the help of an IQR, interquartile range. That IQR we can understand from the last term of a descriptive statistics, I think, which we forgot to learn, or even I forgot to like make you understand. That is nothing but a percentiles. Okay, so in tomorrow's session, so before go for the hypothesis testing, I will tell you about the percentiles. And now you have an idea of this Numpy, so even you can try to check the percentile. You can try to find out the percentile by using the Numpy also. Okay, so even Numpy is having a lot of like there are a lot of things which you can do with the help of Numpy. So after today's session, I will put like 2 notebook in your like I will give you the drive link, and in that drive link I will put like 2 notebooks for sure. So one notebook is covering entire data types of Python. Okay, so starting from string to like sets, and definitely here I am not able to cover all the like functions, all the built-in methods for each data type. Okay, definitely, and that thing is not possible also. But there in that that notebook is maybe 24 or 25 pages, and you are able to find a more functions, more methods, more properties with respect to this like data types. Okay, the second notebook which I am going to put on that drive link is the Numpy. Okay, so there are a lot of things which you can do with the help of NumPy. So even I will try to make you understand also those functions, the like most important function with respect to our data science like session. But you can go through that notebook, and definitely I'm pretty sure that you are able to understand like 90% of the concept. The rest and of the concept which you guys are not able to understand, so you can definitely ask me in an in the session itself. Okay, so guys, just try to do like practice over this whatever we have learned today in a Python. So you can just open the Google Colab notebook. Okay, so even if you don't even if you don't need to like install all the things, you can directly open the Colab notebook and you can do your job. Okay, if you are able to do like in a local system, that is also good, but if you're not, then you can just open this and you can do your job. Okay, so guys, this is what you can like try to understand, and for the for tomorrow's session you can learn a bit of hypothesis testing, because that is what we are going to understand in tomorrow's session. Okay guys, so with this I think we can wrap up today's session. And yeah, if anyone having any doubt, so you guys can ask, or we can end this session for today. Okay, guys, anyone is having any doubt?
Shivam, I have a doubt. In Google Drive, so what is the Collab notepad, right?
Collaboratory notebook. It's Google Collaboratory.
But I am unable to search that one.
It's Google Collaboratory. Okay, you can search it by if you write on Connect More Apps, or even you can try to install the the requirements which I have sent, like the links I have shared yesterday, or even I will share the link in with the Ruby ma'am, and she will share in a WhatsApp group. So you can go through that link and try to install the requirements, and you can try to run the same thing on your local system. Even this like Collaboratory is pretty easy, because here you do not to need any kind of installations and all. So you just need to go on your Google Drive and make a right click over there. You are able to see something more. Okay, so if you click on the Connect More Apps, so there in a search bar, you can try to search for a Google Collaboratory. Okay, or you can simply write Collaboratory, COLAB, and then you are able to
Shivam, I think you have completed it, right? For today. Hello. Ma, am I audible? Hello.
Yes, we can. We can.
Okay, I hope he has completed. Huh? Hello, Gajalakshmi, kindly respond me.
Ma'am, you are audible, ma'am.
No, what he has left the session. Does he completed the session or what?
Yes, ma'am. He completed, ma'am.
Okay, then we can end the session, no?
Yes, ma'am.
Ma'am, I have one question. So, can you share that note? So yesterday, the Shivam told, right? Statistics notes.
Sir, yesterday's material you need, right?
Yeah, material, yes.
Okay, sir. I'll let you know and I'll share in the group, sir. Thank you so much. So, anything else?
No, we are good. Thank you.
Thank you so much. Thank you, everyone.
Ma'am, just now sir said he will share the
data types, two notebooks that you will share that in WhatsApp?
Yeah, he will share it to me and I will share
Okay,
it in the
fine.
group.
Okay, yeah, thank you.
Thank you so much. Thank you. Thank you everyone,
Thank
and
you.
kindly end the session, ma.